CloudDB, shaping your new normal.
All right. Good morning, good afternoon, good evening, wherever you are around the world. Welcome, everyone, to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you will be able to have access to our replays until December 30. I would like to say thanks to our Oracle user groups and Java user groups, all 16 of them, that made this event possible, and also our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now, for today's session, 3 Bridges to the Cloud, Moving Data from Oracle Database to the Cloud by Gleb Otochkin. Please feel free to ask questions at any time by using the chat window on your right lower corner of your screen, and Gleb will be answering all questions by the end of this session. If you have any issues during this session, also you can use the same chat window, and I will try to help you the best I can. Now, without any further ado, please, I leave you with this amazing session by Gleb Otochkin. Gleb?
All right. Thank you, Francisca. It was a nice introduction. Let's start. We're going to talk about how we can move data from Oracle database to the cloud. And it is not about moving data from Oracle database to Oracle Autonomous Database or from Oracle database to any other Oracle database, but rather little bit different case when we move the data from Oracle database to third-party cloud. It is not Oracle Cloud. It could be Google public cloud. It could be AWS. It could be Azure. So let me introduce myself first. My name is Gleb Otochkin. I'm working as a senior consultant in the Sourced Group. I was working with different IT technologies for many years, and I've worked with data integration, Oracle engineering system, virtualization. I did a lot of performance tuning, worked with big data and some cloud technologies. Currently, I'm working primarily in the cloud and not strictly with Oracle database, but my main area of expertise right now is Anthos Config Connector and Anthos Config Connector and Kubernetes. But I'm still keep my eyes on all Oracle technologies, on all Oracle development as well. So here my email, blog, and Twitter handle. I live in Ottawa, Canada. I run a lot in different weather, in different countries, in different marathons. And here the dog. The dog is responsible for a piece of white fur on my head right now. A couple of words about the company. We are part of the Amdocs company group, and we are a cloud service division of Amdocs, probably on the front of cloud adoption and technology in Amdocs. Working for last 10 years, doing a lot of amazing things in the cloud. So let's move forward and talk about why and how we can move the data. The first question is simple: why we need to move data from Oracle database. Traditionally, Oracle database is a transactional database for high OLTP workload. That is probably the main benefit of Oracle Engine, to handle huge transactional workload, providing proper isolation between transactions, and ability to handle and scale all the performance without impacting the performance. That is great, but from other side, when it comes to report, Oracle is great engine, but in many cases, people want to consolidate data from several databases to one big data lake, data warehouse. And in recent years, the main target for all the data warehouse is a cloud. And let's say, yes, we can use Oracle database in the cloud as main data warehouse, but in reality, yes, it is possible, but probably it is more suitable for if we decide to use Oracle Cloud as our main platform. But what if the company's decision is to use Google Cloud as the main engine for transformation? And sometimes it is just political decision. So I'm not going to chase down why people choose one or another cloud, but rather I would discuss technical aspects of that. So sometimes we need to just schedule offload with manual transformation. It is possible, it is easy. You upload data to flat file, to some different formats, CSV file, whatever. Then you apply some pipeline to get that data and put it to the cloud storage. And the cloud storage can be different. It could be different way how you present data in the cloud. It could be Azure Data Lake. It could be Google BigQuery. It could be something else. It could be Redshift in AWS. And that is great, but sometimes it is not enough. And business asks, can you continuously replicate the data as fast as they generated to the cloud to have an exact picture what is going on right now? Sometimes to have some kind of dashboard to make a proper decision. Sometimes it is just way how the business operates. And today we are going to talk about 3 different tools. I'm not going to embrace and explain all possible tools on the market. There are tons of those, but I would rather talk about the tools I have experience with and I was able to see in real life. So, and all 3 tools I'm going to talk about can do initial full offload of the data and then replicate the data continuously. Not always synchronously. It is not always even asynchronously. It could be some kind of half batch replication in some cases. I will talk about that a little bit later. But that is what is our main subject. Just have a look inside 3 tools which is available in the cloud. And the use case for that is going to be a destination Google Cloud and particular BigQuery in Google Cloud. That engine have got a pretty good attention lately and provides a good opportunity, good way how to work with the data. So let's move forward and discuss how we can do that. So the tools we are going to discuss from 3 different vendors, and one of them is Oracle GoldenGate, pretty known tool on the market since 2007 probably, or 2006, I don't remember. I started to work with GoldenGate when it was not bought by Oracle in 2008. The second tool is Kafka, but not just Kafka, vanilla Kafka from Apache Kafka project, but rather the enterprise version of Kafka from Confluent company. Confluent company, if you don't know, is probably the main driving force behind the Kafka development. And they developed Confluent Enterprise and Confluent Cloud platforms, which provides Kafka as a service and more enterprise version, more convenient version to work with the Kafka. Also, they have some commercial connectors, and connectors, it is how they can communicate with different source and target engines. And the third tool we're going to discuss is relatively new tool on the market. It is Google Cloud Datastream Service. It is maintained by Google. It is Google Cloud Service. And why I include that particular service? Because we are talking about replicating to Google Cloud BigQuery, and it is quite naturally that we look what Google Cloud have to offer now us as a tool to perform the task. So let's start from probably the oldest and most known engine to Oracle GoldenGate. So let's talk a little bit about architecture, general architecture, how GoldenGate works. We all know Oracle database generate reader logs and they transform to archive logs, and all information, all changes in Oracle database written down to reader logs. As a matter of fact, they are written down to reader logs before even be able to be committed. So when you change the data in the Oracle, first Oracle does is to write the changes to log writer buffer. So log buffer, it is the first destination for changing data. So, and then after that, it is written to undo, then to tables and everything else, and then eventually they will be committed. So the GoldenGate extract using internal Oracle capture to capture all the changes happening in Oracle database, get the changes, put to the queue, and put to the trail file. Just to keep in mind that we are talking about committed changes. So you probably know that data are going to read a log before they are committed in the source database. So the GoldenGate has a way how to keep track on uncommitted data and mark them committed or non-committed before putting to trail file. So in trail file, you have already committed completed transactional data. Then the data pump, and on the source, we are talking about GoldenGate for Oracle database. That is different from Oracle GoldenGate for big data, those two different engines. So the Oracle GoldenGate for Oracle database get the data, put to trail, and then use its own data pump, it is GoldenGate data pump, to put the data to remote trail file, which represent trail file will be on the Oracle GoldenGate for big data. So let's say if our GoldenGate works on the source Oracle database and our destination GoldenGate for big data in Google Cloud on some virtual machine or virtual machines, depending on what kind of configurations we create, because we can install to some kind of cluster on the destination side. Then it is going to collector, then it is going to trail file, and GoldenGate for big data take those data from trail file and put it to destination target. And when we talk put to destination target, it reads the trail file, read the data. It can apply some kind of filters, some kind of transformations to the data before putting it to destination. It is you have quite a few configurations you can apply. Also, what you can have, you probably know that writing data one by one to modern data warehouse engines is not efficient, really. And sometimes you want to put data in different formats. You want to put data by several parks, let's say. You don't want to put each changes in the row. You want to park those changes by, let's say, 100,000 changes and then put to the destination target. That Oracle GoldenGate for big data can do exactly the same. So In that case, what it does, it is reading the trail file. It creates a temporary file where it collects the number of transactions from trail file, already prepared transaction, and then get that, for example, 100,000 transaction and push it to the target destination. If target destination not be a big query, for example, it is like storage bucket, and you want to put it to compressed, let's say, compressed ORC file, it is quite efficient to get those 100,000 and then compress it after and put to that Avro or ORC file. So that way, GoldenGate can save the space, improve performance, and work efficiently with the data. So, and the target itself as a source for Oracle GoldenGate can be completely different. Oracle GoldenGate can work with different source relational and non-relational databases, and it can dump the data to different targets. As I said, it could be AWS storage, S3 storage, it could be Azure storage, it could be Oracle Cloud Storage, it could be BigQuery, and the number of targets is quite impressive. So that is the Oracle GoldenGate. It supports most of Oracle databases, of course. So on on the GoldenGate for big data, it is different from Oracle GoldenGate for Oracle database. When we talk about the capturing data, we are talking about Oracle GoldenGate for Oracle database, and you can choose the version of GoldenGate for Oracle database which supports actual version of Oracle you have, and then put exactly that data will be put to trail file, and trail file is some kind of has its own internal structure with unified data type, which can be understood by GoldenGate for big data. It has some kind of limitation and restriction. For example, you cannot probably use GoldenGate for Oracle 10G database and put to trail file and expect that Oracle GoldenGate for big data will properly read your DDL changes. That was never worked for me, but in reality, we are not talking about Oracle 10G here. I believe some people still have it, but I didn't see it recently in any enterprise. But again, it is, of course, possible. It supports most of the existing data types, and it is quite different from some other engines, even if it is based on log miner technology in some sense. It works with more data types than most other technologies based on purely on WMS log miner package. That's from my experience. It is supported by Oracle itself, and it is good and bad. In my opinion, first, it is good because it is the single vendor for support. It is enterprise support with tickets and proper reaction. But when people say, oh, buy Oracle because you have Oracle database and Oracle GoldenGate support by the same vendor, yes, this is the same vendor, but from my personal experience, it doesn't really help to improve anything, because support for GoldenGate and support for Oracle database provided by different people, and they don't communicate to each other very effectively. It is just from my experience. So it is good, and on the same time, it is not. I would not put too much attention that it is the same vendor. It is just support, and support could be good and could be bad, depending from actual engineer working with your case. GoldenGate has really good performance and reliability. Sometimes we have GoldenGate on the source and target working by weeks without any issues, without any hiccups. And in general, I had a huge positive experience working with GoldenGate in the past, and it is good, reliable engine from my point of view. Also, it delivers data directly to BigQuery. You don't need any additional pipeline, any additional massage and transformation, or relying to any other mechanism. So it can dump data directly to BigQuery. Has good login tracing. You have different types of login for different, let's say, components of GoldenGate. So manager, you have log for replicate, and you have actual log for big data replicate. You also have an G4 log, which is quite substantial in details. It has proper good documentation, which can lead you through installation. As a matter of fact, I know it is probably not most popular opinion, but I'm using official documentation in most cases of my work. I know there are tons of blogs, and I'm writing some blogs sometimes, and blog is essential except from documentation, which allows you to do the particular stuff. But sometimes official documentation has more details how to do that, and sometimes it is quite vital to deliver a really good job. Yes, you can start from the blog, check if something is working properly, but eventually everybody has to read documentation. And if documentation for product is really good, it helps tremendously. It has multiple useful features. One of them, for example, is a heartbeat table, which keeps replication ongoing all the time, even if you don't have real transaction on the source. It helps to understand whether it is died or it is still alive, which is quite important for monitoring. And you have a graphical user interface. It's not only a command line interface as in old classic GoldenGate. You have actual web interface with REST API, and you can use it. So that is GoldenGate. I can talk about GoldenGate probably a couple of hours, but let's move forward and talk about Confluent Kafka Connect. So the Kafka is an engine which can pipe data from different sources to the universal topic, unifying the data format by using Avro or any other formats, JSON, Avro, and other. And then from that topic, you can use the data and put it to the sink different connects as well. So, and since the connects are developed by open source community, you have tons of different options. And it means you can feed from one source multiple different destinations, and from multiple different destinations, you can dump the data to one source. So it is many to many to one particular engine in the middle. So how it works? In case of our, let's talk about our case. We have Oracle database on the source. We have BigQuery on destination. So Confluent CDC, Oracle CDC Connector, create a task, and that task is running log writer in the source database. It is connecting as a user. You provide username, connection, stream, and everything else. It connects as a user to the source database. It runs log miner engine there. It runs some other magic behind the scenes. And as soon as you have transaction in read a log, it takes that transaction and put it to the topic. Also, behind the scenes, it runs another, for example, task. It takes the initial table snapshot before putting any transaction to the topic, and put all that table data to the topic to replicate to destination side. And then it starts to feed the topic with all new fresh transactions. The topic is quite scalable. You can have topic partitions. You can split source table to partitions. It is quite highly available and scalable architecture by design. Then when you have the data in the topic, and the topic, it is just continuous writing of the data, you can read the data from the topic by a client. And in different cases, you can have just simple client. You can run it from command line and give me all the data from the topic. But on the same time, you can have BigQuery connector as a client for that topic. So in that case, what you specify what you need for that. You need to first you need to authorize that your BigQuery connector to the BigQuery. It means in Google Cloud, and you have different ways how to do that. In general, you have to provide some kind of credentials, and credentials. Not recommended way is JSON file with key for service account or for user account, and then using that JSON with authentication, that your connector can connect and push data to BigQuery. But probably the better way is to use instance principals and service accounts or some other ways. So essentially, in any way, you authenticate in the Google Cloud, you have authorization and put data to the BigQuery, and you create, you have the data set parameters, you have pre-created data set, and you create tables with your data. First of all, of course, you put the initial snapshot of the table, and then on the top of that, all the changes to the table. One thing I have to mention about any of those engines. When we talk about replication from, for example, Oracle database to Oracle database, from MySQL database to Oracle, from Oracle to MySQL or any other relational database, we are talking primarily about state of the data. It means you delete row here on the source, the row is going to be deleted on the target. You create new row on the source, it will be created on the target. You update row on the source, it will be updated on the target. But when we talk about GoldenGate for big data, Confluent, Kafka, or Datastream, what it is going to happen, they will run changes of the data. It's like journal of changes, and every change in the data, whether it is delete, insert, or update, will be as additional row on the target. If you update the same row 10,000 times, it will 10,000 times rows on the target side with type operation update. What is important is to have some kind of way to uniquely identify each row on the target. In case Oracle to Oracle, or when Oracle write the data to reader logs, by default it is using row ID. But row ID doesn't make any sense for BigQuery, for example, right? And it is why it is strongly recommended to have unique key, primary key, to uniquely identify each row, to be able to identify the sequence of operations with that row to represent the final data state. I hope you with me about that. So again, it is journal of changes on the destination side. So that is Kafka Connect, how it works. It is installed and registered in Confluent deployment. So the Oracle CDC Connector, it is commercial Confluent connector, and it is not for vanilla open source Kafka. Now we have version 1.4, it supports container, non-container architecture version from 11G to 19C, and actually it works with 21C too. Even nobody is going to use it as a proper, let's say, production release. It is just innovation release. It will be gone soon. So, but the fact that it works with 21C, probably it is a good thing. Supports most of the existing data types with some limitations related to log miner and how it works. All detailed limitation you, of course, can read on the site, Confluent site. It is supported by Confluent itself. It is not open source community support. It is enterprise connector. From my tests and from my experience working with it, it has good performance, reliability. The first version, when I started it, and I blogged about that probably a year ago or so, it had some kind of glitches and some inconsistencies and some interesting stuff, but it moved forward significantly since that time. So it is in active development. It has graphical user interface if you prefer that, or you can use REST API interface and use just the core utility and put the data there, configuration in JSON, and so on. Has, from my point of view, has rich login for troubleshooting. Sometimes I found too many logs. It's quite easy to lost yourself. So if you're familiar with Gleb and cat and everything else, it would be easy for you. But number of logs is astonishing. I was able to troubleshoot most of the stuff when I hit the issues. And of course, it has a great horizontal scalability. It is what I found about the topic about how you can partition the data and how you can scale the data. So also, I forgot to mention, it is quite easy if you don't want to install anything. You have Confluent Cloud, and Confluent Cloud, I will probably add it to presentation. And Confluent Cloud, it just by several clicks, you're gonna set it up. Really, it is literally simple, and you have step-by-step instruction on Confluent site. So, and it is easy. You can just get Confluent, subscribe for Confluent Cloud, test it, then scrap everything out and decide later whether you like it or not. So I recommend everybody to try it. It is quite interesting. Right, how we 12:34. Great. So we still have time, and let's talk about Google Cloud Datastream service. We're talking about moving the data to Google Cloud in that particular case. How, and of course, it would be most logical to first use Google service for that. And Google Cloud Datastream Service, it is using relatively the same technology as other replication tool from Oracle database. It is using log miner. So Oracle CDC Connector connect as user to the instance. You provide connection string and everything else, and all the parameters. It read, but not read the logs. As a matter of fact, it cannot read the logs. What it reads is archived read logs or archived logs. So when you update the row on the source, commit row, it is not going to be replicated right away. It will be replicated as soon as you switch the log, and current log will be written down as archive log. Then Datastream automatically pick up that archive log, parse it, and put all the transaction according to your filters to the data stream. In the data stream, it will transform it to internal unified format when you have mapped data types, Oracle data types to Datastream data types. and then create Avro or JSON file and upload it to Google storage bucket. So far, only way as a target is supported. It is on the Google storage bucket. You cannot move it directly to BigQuery. But Google provided some kind of template for data flow, how to pick up from the storage bucket and put it to BigQuery. That is good. What is bad, you have to do it after that. So it means you have to depend on another service to get the data to destination. That's one downside. Again, it is using Oracle Log Miner, works with only archive logs. What it says and what I found from the test. So you're probably aware that Oracle writes transaction to read a log as soon as you create transaction. You change the row, even before you commit it, it is going to be in the reader log. So what would happen if you don't commit the transaction but switch your archive log? Of course, that log will have that transaction. And that transaction will be written down to the destination side, even if it is not committed yet. But when you roll back, for example, that transaction later, that rollback will go to the reader log as well and will be switched to archive log. And that rollback, which represents itself as a delete for that row, will be written as well to the destination side. And they will like compensate each other when you want to have some kind of final picture of data state, right? So, but again, before you go to rollback transaction, you potentially have some kind of misleading information in your data. So destination format can be JSON or Avro. It could be zipped or non-zip, and data flow can be used to pass the data folder to BigQuery. So that is data stream service. I found what I found is first it is not actually right data. It doesn't supports non-container architecture. It doesn't support container architecture, and it is not working. So it is copy-paste issue. It doesn't support 21C. So it is quite interesting. It doesn't support non-container architecture. It cannot work with pluggable database. But technically, you can do the initial load using that. So what, even for 21C, which doesn't support non-container architecture at all. So what you can do, you can create a data stream. You can start data stream task from command line, gcloud command line, with option force. And then what it will do for you, it will dump all the data from the source to destination. And it will be fine. It will be just create your data set on destination side in the storage bucket. But as soon as you try to change some data and switch archive log, it will provide the error. It cannot replicate the data from pluggable database. That what I found. Of course, again, it is from my test. I'm not working for Google. Maybe I'm doing something wrong. Again, it is what I see in the behavior and in documentation as well. So it doesn't work with CDB architecture. It supports most of the standard data types in Oracle database, but it has a long list of unsupported. So before making a decision whether it works for you or not, I would strongly recommend to go and see if your data type, one of the data type, will not be supported. For example, multiple data types will not be replicated, but any value with those data type will be just represented as a null on destination side. So that's one caveat you need to keep in mind. It's supported by Google, and it has initial offload and replication modes. When you start your replication, it drives the initial offload of your data. For example, you have 500 gigabyte table. It will take the table, put to destination side, and then replicate all the changes for the table. The price is different for initial load and replication mode. Initial load is much cheaper than replication. And why it is important? Because it is priced by gigabytes, how much data you replicate. So if you have huge terabytes data on the source, that initial offload will be not so much expensive as you, for example, replicate that by gigabytes. Usually the changes in the data are much smaller than data set. So, let me go here. So it is small comparison of the different solutions. GoldenGate versus Confluent Kafka Connector and Datastream service. I just put it together, and if you have a look for all pros and cons, I would probably, it is my opinion, what I would use. First, if I need replication from Oracle database with special data types, and I know how it works, I would probably choose GoldenGate. And of course, if I can pay the price, because GoldenGate priced slightly different than Confluent Kafka Connector Datastream service. So if for example, we have source database as 8-node real application cluster with tons of CPU, it would be quite costly. Because you pay for per CPU for Oracle GoldenGate for Oracle database per each node of the cluster, and then you pay half of that price to Oracle GoldenGate for big data and destination. So it is quite expensive. Also, it depends where your data are and what kind of transactional workload is. So GoldenGate, good choice with some caveats. Also, it has some, not problem, it doesn't have embedded high availability and horizontal scalability. High availability can be solved by creating a cluster and so on. But again, it is some kind of things you have to think about. The second choice, and in many cases, probably the first choice, would be for me a Confluent Kafka Connector. Supports most of the Oracle versions. It is universal in destination where you want and how you want to put data. You can use tons of services on top of that with KSQL or any other services, streaming and everything else. So it is in very active development. It has good performance, scalability, and it has cloud version in GCP, which relieve you from management part for that. You don't need really put too much effort to manage the Confluent Kafka Connector itself. So, but again, it depends also on some Oracle source versions and features and data types, which might not be supported by current version of Confluent Kafka Connector. So, but again, I would be divided between two choices. GCP Datastream service is probably good, but only in limited cases. The first main blow is it doesn't support container architecture, which is probably the main architecture in Oracle database right now. Everybody is moving to pluggable databases right now. That's one problem. It has really limited data types. It has problem with some data types. And when we talk about the complete solution, yes, it is good to have it as a service, but then you need to run another service on top of that to get the data, for example, to be queried. That is additional issue. And one issue is, in some cases, if you have a security team really paranoid about security, really dedicated on security, you can have probably internal native Oracle encryption, but you cannot have SSL, TSL encryption. So that is not supported. Again, I can be wrong, and maybe Google folks can correct me, but it is what they say on the documentation. And I was not able to make it working with SSL. Maybe I was doing something wrong. But it has its own benefits as well. It is easy to set up. It is absolutely transparent pricing model. It is automatically scanning, and it automatically resumes after fire. It is not bad service at all, but it is limited for some certain cases. So that's probably it for today. It's 47 minutes. I am 2 minutes over time. I hope I help you to navigate between those tools and probably provided some valuable information for you. Here, my final page for Q&A. And if you have any questions, you always can ping me in blog, LinkedIn, in by my email or Twitter. Thank you very much. And I will upload the presentation itself to the site after all.
Thank you so much, Gleb. Thank you so much for your time. I'm just waiting to see if there's any question coming through the Facebook. In the meantime, if you're watching the replays or you have you want to ask personally directly to Gleb, not by the chat, please feel free to contact him by his Twitter handle or email. You can see right there on the screen his email, Gleb Otochkin @SourceGroup. You also have his blog, and also you have his Twitter handle is Sky_VST. And Gleb will be answering all your questions if you want to do that offline or after watching the replays. Yep, looks like it's no questions coming through Facebook. In that case, Gleb, thank you so much for sharing your knowledge with the community, not the Asia Pac only, our global community. Also for being awake so late, almost 1 a.m. for you. And please take care and be safe, and same likewise to everyone watching the webinar.
Thank you very much.
Have a wonderful Friday and weekend, everyone. Bye-bye.
Thank you. Bye-bye.
CloudDB, shaping your new normal.